In our previous videos, we looked at graphing lines given information, and then we looked in more detail at what we mean by the concept of slope, the slope of a line. In this video, we're going to look at finding equations of lines given information. And we're going to primarily write the equations in y equals mx plus b form. And one of the main reasons that we're going to do that is that if we can write it as y equals mx plus b, remember y is the same thing as f of x. So we can write it in function form. And that makes it easy if I have an input x to find my output y. Let's say that we have a line where we know a couple of points. For instance, say we have the point 2, 3, and then we have the point -1, -1, and we have an equation, a line through those 2 points. So what we're going to do is look at how can we find the equation of this line? How can we find the function that goes through those 2 ordered pairs and has the shape of a line? We saw in our previous video that we can find our slope first. And remember, slope is change in y, our rise, how much we're going up or down, over run, our change in x, how much we're going side to side. So I want you to pause the video for a minute, find the slope of the line going through those 2 ordered pairs, and then turn the video back on. So we take our change in y, this y minus this y. So I have 3 minus -1 over my change in my x's, this x minus this x. And I had to start with this one because I started with the y here. You always have to start with the same point. So I have 2 minus -1. So I have 4 over 3. So my slope of the line I'm trying to find the equation of is 4/3. And I do want to kind of double check. I have a positive number. I am increasing from left to right. So that's something I need to kind of mentally check every time. What we're going to see now is that if I know my slope is 4/3, I can find an equation of the line using either of the 2 points that are given. And I'm going to go ahead and choose the point 2/3, or 2 comma 3, because it doesn't have any negative numbers in it. But I could have used -1, -1, because what we're trying to do is find an equation of a line that if I plug the 2 in for x and the 3 in for y, that I get a true statement. I can use what's called my slope point form to do this. This point that's given is going to be my x1, y1. My m is my slope that's given, and the x and the y in the formula are just the x and the y that remain in the equation of the line. So I can plug all of my numbers in, and I have y minus y1, which is 3. My m is 4/3, and x minus my x1 is 2. And then I can distribute the 4/3, then add the 3, and get y equals mx plus b form. Go ahead and pause the video and finish writing this equation. So I see that when I distribute the 4/3, remember if I multiply 4/3 times 2, that's 2 over 1. I multiply the numerators, I multiply the denominators, and I get 8/3. And then I can add the 3 to both sides. And I see that if I have negative 8/3 plus 3, 3 is the same thing as 9/3. So I need to try to get the same denominator here. So I'm going to multiply this by 3 over 3, because that's just 1, and that gives me 9/3. And negative 8 plus 9 is 1 over 3. So what I have here is an equation of a line that goes through these two ordered pairs. And a quick way that I could see if I have the right answer is remember that this number, 1/3, is the y coordinate of the y-intercept. And if I look back at my graph, it looks more like 1/2 here, but that's because I'm not a very good grapher. So that could be 1/3. So that tells me that I think that I have the right equation. I have not made a mathematical error. So just to review what we did here. Given 2 points, find an equation of the line. What we did was we found the slope, we plugged slope and 1 point, and you can use either point, into the slope-intercept form. I'm sorry, the slope point form. And then we simplified to get our y equals mx plus b form. So that was our process for finding the equation of a line given 2 points. Let's look at an application of this. Let's say that I know that in the year 2011, $42,368 books were checked out of a library. And let's say that I know in the year 2013, $41,112 books were checked out. And what we're going to do is to find a linear equation that models the number of books checked out in a given year. All right. Let's talk about some terminology here. The word models means finding a function that we can use to predict what's happening in the real world. So in this case, a model is going to be a linear function. And we know that if it is a linear function, it's going to have the form y equals mx plus b. So if it tells me to find a linear model, it's telling me to find a function in linear form. My x is my input, my independent variable. That's going to be my year. So x is going to be the year. And when you're using years, it's very, very common to set the first year that you're using to 0. So we're going to say that x is our year, and it's going to be the number of years past our initial year, 2011. So that means in 2011, x equals 0. We're also going to find our output here, our f of x. And we're going to see that our f of x, which is our output, our y, is the number of books. That's our dependent variable. So if I write my two ordered pairs from my two pieces of information here, I'm going to see that this first piece of information is 1 point, and this second piece of information is another point, another ordered pair. And remember that in 2011, x equals 0. So what I want you to do is to pause the video for a moment and write our two ordered pairs. And just to give you a hint here, I'm going to put a 0 right here. That's our first ordered pair. All right, so my first ordered pair in year 0, the number of books is 42368. I didn't leave myself nearly enough room here, so let me erase these and start again. So we have 0 and 42368. And then our second ordered pair, we're in the year 2013. So if I take 2013 minus 2011, that's equal to 2. So my second ordered pair is the year 2 and 41,112 books. So now we are actually at exactly the place we were in our previous example, where we have two ordered pairs and we can find the equation of the line. So I'd like you to try to look back at what we did in the first example, find your slope, plug into your point slope formula, and find the equation of this line in function form. So pause the video and then come back. All right, first thing I'm going to do is find my slope. The number of books is my y's, so that's in my numerator. And since I started with the first point, I have to start with the second point. And I'll use my calculator here. I get 1,256 over -2. And since I'm talking about the rate of change of the number of books, I don't want to leave it as a fraction here. I'm going to go ahead and do my division here. And I'm going to have -628. So that slope is talking about the rate of change of books per year. And notice we have a negative here. That means the number of books being checked out is decreasing. And that makes sense because this is a smaller number than this. So this is -628 books per year. That's my rate of change. But just doing the math here, I have that my M is -628, and I can use either ordered pair. So I'm going to just go ahead and use the 0, 4, 2, 3, 6, 8. And as soon as I write that point down, I realize this is 0. That means that this is not only just some random point on the line, this is a special point. This is the y-intercept. So I don't actually have to plug into the point slope formula. I can just plug straight into my y equals mx plus b. But I can only do this if I have the y-intercept, which means that there's a 0 for my x. So this is going to be my b, the y-coordinate of my y-intercept. This is my m, my slope. So if I write this in function form, I have f of x equals -628x plus 42,368. And that is a function that models the number of books checked out in a given year. Let's say I wanted to use this model to predict the number of books checked out in 2018. What this is saying is, given a year, given an X, find the number of books. So we're going to find Y. And we remember that X is the number of years past our first year, 2011. So we're going to have that X is equal to the number of years that 2018 is past 2011, which is 7. So we know X equals 7, and we're trying to find f of 7. And we can just do that by plugging 7 in for X in our model and evaluating that. So what we're saying here is that if we started in year 2011 with 42,368 and we are subtracting 628 every year for 7 years, that's exactly what the model is doing for us, what the mathematics is doing for us. So I'm doing my math here, -628 times 7 plus 42,368, and I get that we would expect to check out 37,972 books in the year 2018. And this is why learning about algebra and learning about functions is so important. We're going to see as we move through the semester, if we know some data, if we know what's happening in the actual world, we can find a model find a mathematical formula that models what's going on in the real world, and then we can use it to find additional information. In our next video, we're going to look at a couple of special lines.